right. So let's do a little exploration here to figure out the next property. So, um, so let's just kind of go down the list here. So I know 2 squared is 2 times 2, right? If I write it in expanded form, and that equals 4. Okay, 2 cubed is 2 times 2 times 2, so that equals 8, right? 2 to the 4th, product of 4 2's, so that equals 16. 2 to the 5th would be a product of 5 2's in expanded form, so that would equal 32, right? So if you notice, to go from 4 to 8 to 16 to 32, if we're going up the list, what are we doing? We're multiplying by 2 each time, right? So I multiply 4 by 2, and that gets me 8. 8 by 2, and that gets me 16. 16 by 2, and that gets me 32, okay? Now, what if we want to go down the list? So how would I get from 1 to the next, right? So if I want to get from 32 to 16, I would divide by 2, right? 32 divided by 2 equals 16. 16 divided by 2 equals 8. 8 divided by 2 equals 4. 4 divided by 2 equals 2, right? So the next one would be 2. And so this kind of goes back to what we've talked about a few times, which is anything to the first power is itself, right? So, and that can kind of go both ways. So if I have a to the first, that equals a. So in other words, once again, like we saw in an earlier problem, if you see a variable by itself, or even a number by itself, you know, like 5, that equals 5 to the first power, like there's an invisible 1 there as the exponent. All right, and you can also simplify, it goes the other way too, where if you see anything to the first power, you can just simplify that to the base itself, okay? All right, so now here's the thing, here's the tricky part. What is anything to the 0 power? You know, when we multiply anything by 0, we get 0, right? When we divide 0 by something, we get 0. 0 divided by anything is 0. When we have something divided by 0, we get undefined. And so, so 0 is an interesting number and has some interesting properties. But in terms of exponents, if we have a 0 exponent, let's see what it does. So if I want to go from this level down to the next, I would do what I've been doing every time. I'm going to divide by 2. And 2 divided by 2 is, that's right, 1. Okay, so anything to the 0 power is 1, right? Because if I'm trying to go from a to the first to a to the 0, I would divide by whatever a is. And so a divided by a is going to be 1. So anything to the 0 power is 1. All right, so that's the property that we're going to talk about next. Okay, so we'll save this conversation for later. Negative exponents, that'll be in section 4.2. But you can think about it by doing the same thing. Okay, how do I get to the negative 1? Divide by 2, right? So that's preview for what's to come. But for right now, I want you to remember that anything to the 0 power is 1, except for there's one exception to the rule, and we talked about it a second ago, is 0 to the 0 power, right? That's a mystery right now. Like there's some different trains of thought in mathematics. Some people argue it's equal to 1. Some people argue it's undefined because technically you would be dividing by 0, right? As you go, if you go from 0 to the first to 0 to the 0, you'd be dividing by 0, which would be undefined. And then some people argue that it's 0 because 0 multiplied by anything, a product of however many zeros you have, is always 0. So anyway, so those are the 3 arguments or cases. So you can think about where you fall in that debate. All right, so let's try this out. So we know that anything to the 0 power is 1, except for 0 to the 0 power, right? So a lot of times you'll see where a is not 0. Okay. All right, so basically, number 14, you see anything to the 0 power, that's going to equal 1, right? So that's your answer. So you can just set it equal to 1, and that's it. So here, 16, once again, anything to the 0 power is 1. Okay, as long as that base is not 0, your answer is 1, right? And that's why they say non-zero real numbers, because if you did have a 0, then once again it would tie into that controversy, and it's up for debate. Okay. All right, so number 18. So anything to the 0 power is 1. So here we have a little order of operations situation going on. We have some we have some exponents, and we have some subtraction, right? So what comes first? Exponents, right? So I'm going to do exponents first. So 4 to the 0 power is 1. Since this negative is not inside parentheses, that's going to stay what it is. So it'll be negative 1. And the same thing with this 8 to the 0 power, that equals 1. The negative in front stays there, so it's going to be negative 1 minus 1, which is negative 2. Okay? All right, number 20. So, once again, anything to the 0 power is 1, right? So, we do have some, if we're talking about PEMDAS, once again, doing what's inside the parentheses would be what we operate on first. However, whatever this comes out to be doesn't matter, right? Because we have a 0 exponent. So anything to the 0 power is 1. And so this whole thing just turns into a 1. All right, number 22. We have multiple operations going on here. We have multiplication and exponents. So we're going to do exponents first. Okay. Now, remember, this is the product rule as well. So we could also add the exponents. So 0 plus 2, so we get a to the second. So that's one way to do it. We're going to use our 0 product property and cancel out. A to the 0 is just 1. So 1 multiplied by a squared is a squared. Okay, so either way you get a squared. All right, so anytime you see anything to the 0 power, just cross it out, turn into 1. Okay, and remember that exponents only affect what they're directly touching. So if they're next to a set of parentheses, they affect the whole value, right? Everything inside the parentheses. But if they're just next to a number and there's no parentheses, then they just affect that number, right? Not the number in front or anything like that. They don't affect negatives like we saw here. So they only affect the number that's directly attached to it, okay? Unless there's parentheses, then it affects everything inside the parentheses.